Okay, so the next problem in the lead code we are solving is kth largest element in an array. Okay, so basically here we'll be given the list of numbers and we are asked to get the kth largest element. Let's say that if we sort it right, and even though there is a duplicate value, that's fine. But even though if it's sorted and it's sorted in a descending order, and we should be returning the second element. Okay, let's say that currently if it's sorted in descending order, it will be like 654, right? 654321, correct? So we'll be able to return a second element, which is 5. That is the answer. Okay, and also let's say that instead of 4 there is an element 6. Okay, if we sort it, what it will be looking like is 665321, correct? Again there is a duplicate, that's okay, but we still have to return the second element. That is answer will be the 6 at that in that case. Okay, so this is the problem about. So how to approach this problem, right? So basically we could have done a sorting, right? We could have done a sorting and we could have simply written the second element, fourth element, right? And then we are done here. So but here we are asked to not to sort it, but still we get an answer, we still need to get an answer. Okay, so that is one way. Like sorting was one method, and second what we could do is we could simply find the max element every time. For like for the k is equal to 2, right? So we simply find the max element for the k minus 1 type. Okay, so for example k is equal to, here it will be easy to explain. So k is equal to 4, right? We'll try to find the max element 1 for the first time, and then we'll pop it. We'll remove it. Okay, and then we'll find it, and then again we'll remove it. Okay, and then again we'll like I mean third for the third time, for thrice we'll remove it, and for the fourth time we'll again calculate the max one, and we can get that as an answer, correct? But again that will be like too much time complexity, correct? Every time we are trying to find a max element, that will be of O of n, and also like O of we are trying to remove it, that also will be O of n time complexity, correct? So like I mean it will be of too much time complexity, time complex. Okay, so instead what we can do is we can make use of a heap data structure. Okay, so heap it can be like min heap or max heap. Okay, so or else what we can call it as a priority queues. Okay, that will be kind of a similar term to and also easy to understand. Okay, so queue meaning we first in first out, correct? Whenever we add an element to the queue, it will be that will be the first element that will be popped out, right? That is a queue. Okay, but what is priority queue? Priority queue is like it will have a weightage. Okay, so let's say that I have a number. Okay, this is a number. Okay, and I want to pop the sixth element. Okay, like every time I pop an element, whichever the number value that is greater, right, that will be popped. Okay, or else it's the other way around. Let's say that it's like associating the priority to the each nodes. Okay, let's say you can decide whether if you want to decide like if the number is higher, you can associate it to the higher priority, or it's the other way around. Like you can associate the least number. If it is the least number, it will have the highest priority. Okay, so based on that, whenever we pop, we'll get either minimum or maximum value. Okay, so to classify here, right, heap can be classified into minimum heap and maximum heap. Okay, like as we discussed, minimum heap will be used for a periodic queues which wants the weightage to be less. Okay, whenever we want to pop, let's say there is a list of priorities, but if you want to give the priority to the number which is less, so in that case we will be using the minimum heap. Okay, min heap. And also whenever we want to pop the element which has the highest weightage, so in that case we'll have to pop the max heap. Okay, it's actually heap is kind of like a tree data structure. Okay, so in the max heap always the root node or whatever the root node will be greater than the child node. Okay, and in the min heap it's the other way around, always the child element, always the root element will be lesser than the child nodes. Okay, so these are the things or the information that we need to solve this problem. So to just give a summary what we discussed so far, we'll be using a heap data structure. Okay, in the heap data structure is nothing but equal to priority queue. For a priority queue we can associate the weightages. Okay, like based on the weightages we can classify it as minimum heap or maximum heap. Minimum heap will be associating the will be popping an element. I mean, in the minimum heap, the root element will always be the lesser than the child nodes. In the maximum heap, the root node element will always be greater than the child nodes. Okay. So whenever we pop in the minimum heap, we will always get the minimum value, so that it will be in the priority queue, right? That will be given the more priority. And in the maximum heap, whenever we pop, the root node will be always bigger. So that will be we will be getting the always the higher value that is present in the heap. Okay. So now coming to this problem. So what we'll do is we want the k largest element, right? So if let's say that we push the k largest element, first k largest element to the pop. Okay, like I mean we'll push it, we'll maintain a heap such that we'll always the k largest element. Okay, so what will happen now? So let's say that if you are able to like we want to get the last k element, right? So what we'll do is we'll have one list and we'll push some k elements into it. Okay, and then we'll heapify it. meaning like let's say that we cannot let's say this is one list, okay. If we heapify it as a minimum, if you heapify it, it should have an order, right? Like I mean, in the tree data structure, in the will represent in a different order, right? That should be the order, okay. So we will be storing our numbers. Let's say that at the end, like at the end of the problem, what we need is we need the k largest elements. So if we, in this case, right, what we need is 5 and 6. We don't want other elements, so we will build a list, or we will build a heap of size k, okay. So how to build? First we'll add everything that are present in the nums, okay. Like first k elements we'll add it to the heap, okay. So and then we'll heapify it, meaning we'll be properly order it in terms of minimum heap, okay. So by default this is a minimum heap, okay. If you, when you call heapify, the Python is designed in such a way that to do the minimum heap, okay. If you want to build a maximum heap, you will have to insert a my negative of this number, so that will act as a maximum heap in that case, okay. So now we have a k elements present in the heap, that is the first k elements, okay. We have 3 and 2, but we still have these many elements. So what we'll now do is we'll iterate through this list, and we will keep on checking whatever the root node, right? That will always be the minimum value, that will pop give us the minimum value, which is minimum, okay. Like we'll check that, okay. Like once we get any number which is greater than this, we will swap it out, okay. We'll pop it out and push it, okay. This is easy to understand. Just we can pop it out and push it. This is the one line for both of the action, okay. And also efficient. So coming back to this, so 3 comma 2, right? We had a heap, we had 3 comma 2 in the heap. So once we reach the one is lesser than this, we don't need we don't need this. So once we encounter 5, right? So 5 is greater than the 2 which is present in the node. So what we'll do is we'll do the push pop to this. So we'll insert 5 to the heap. So what will happen? 2 will pop it out, will pop out, and 5 will go and sit there, okay. 3 comma 5, okay. We still maintain the k is equal to 2, and then we'll go to k 6, right? And then we know that 6 is greater than the, like once we heapify, right? So it will be like 5 comma 3, or 5, sorry, 3 comma 5. The root will be the lesser one, right? It will be 3 comma 5. So basically, so whenever we encounter a number which is greater than the root node, so it means that we have something that is greater than the current list. So we'll just add that current, add the new ones, and pop the existing ones. Yeah, that is it. And then finally, whatever that is present in the root node, that will be the kth largest element in an array. So to summarize, we are using a data heap data structure here, okay, and we are asked to find out a k largest element. So we will be building a heap data structure consisting of only these elements, okay. We don't want any like remaining k elements, we just want a kth largest element, so we'll be building it, okay. So as we iterate through, we'll be keep on adding our element to the list, okay. And whenever we identify something, like I mean, the new node is suppose is actually greater than the existing minimum heap, so we'll be swapping it out, like pushing, popping, okay. So that's it. At the end will be whatever the element that is present in the heap node, right? That's the root node, that will be our answer. That's it. Thanks.